All right, so we've already learned how to solve systems of equations using substitution and graphing, and this new method is called elimination. So the goal of this method is to eliminate one variable so you only have one left. All right, let's do an example so you can see what this means. Okay, so this is the simplest example, and when we're doing elimination, we often have equations in standard form. So standard form, remember, is this ax plus by equals c. And you'll notice that both of these equations are in that form. Now, look at the y column here. If you notice that the y coefficients are the same but opposite in sign. Okay, so when we do elimination method, we simply add the two equations. So that means that you just add the constants, and that's going to give me 8. When I add these two variables, they eliminate each other. 5y plus negative 5y makes 0. So we don't have to write anything there. 2x plus 6x equals 8x. And now I just have this equation 8x equals 8, which I know how to solve. I have my x value, and now I can plug it back into either equation to find the y value. I'll choose the first one. You can choose the second one. It'll come out the same. So I've got 2x plus 5y equals 17. In the place of the x, I'm going to put 1. So I've got x equals 1, y equals 3, so my solution is 1, 3. And I might want to just check in the equations to make sure this works. 6 times 1 is 6, minus 5 times 3 is a negative 15, that would be. So positive 6 and a negative 15 makes a negative 9. It works there. I can plug into that one to make sure. Now this was a simple example because these two were already set up to cancel each other out. Let's look at a slightly more complicated example. Okay, in this example, none of these variables are lined up to really cancel each other out. And there's nothing really easy that I could multiply by to make these x's cancel out, but I notice here that if I multiplied this entire second equation by 3, the y's would cancel out. So that's what I'm going to do first. I'm going to try to eliminate the y's. I'm going to take this whole equation and I'm going to multiply by 3. And then I'm going to rewrite the entire equation. So I have to multiply everything in here by 3. 7 times 3 is 21. So I've got 21x. 3 times negative 5y is negative 15y. And 3 times 17. Now this top equation, I'm not going to change. It's going to stay the same. Negative 2x plus 15y equals negative 32. So now notice that these y's are set up so that their coefficients will cancel each other out when we add. Let's do that. All right, I've got x equals 1. I can choose either equation. I'll choose the second one this time. So I'll have 7x minus 5y equals 17. Again, x equals 1. So 7 times 1 minus 5y equals 17. And I've got my solution. All right, one more here, which will take us just one more step in complexity. All right, now, there's nothing I can multiply either of these equations by to get things to cancel out. So what am I going to do? Well, I could try and cancel out the y's, or I could try and cancel out the x's. Since I've done the y's in the other examples, I'll go ahead and do the x's for this time. So I need these to be the same coefficients but opposite in sign. The easiest way I can do that is to make one a 12 and one a negative 12. So I'm going to take this, I'm going to multiply it by a 4, That'll give me a 12x here. I'm going to multiply this one by a negative 3. Negative because I need this one to be a negative 12. Okay, now I'll write my second version of each equation over here. I've got 12x plus 8y equals 4. Make sure you multiply everything in this equation by 4. Here I'll multiply everything by negative 3, so I've got negative 12x minus 9y equals a positive 6. All right, so now I just go ahead and add. That makes 0. Here I've got negative 1y equals 10. So y is going to be negative 10. Now I take this y and plug it back in. Okay, so I'll choose the first. 3x plus 2 times negative 10 equals 1. So I have my solution, 7, negative 10. So again, you're trying to eliminate one of the variables and solve for another.